AP Statistics Final Project. We created a survey regarding the relationship between time spent on extracurricular activities and weighted GPA for Leesville High School students. Using an Excel spreadsheet, we picked a random sample of teachers to pass out the surveys. Once we received the data, we organized it into a table on a spreadsheet and created scatter and residual plots for the data. The scatter plot didn't appear to show any relationship, so we conducted a two-sided linear regression t-test to confirm if there was an association. If there was any correlation between the number of hours of extracurricular activities and a person's GPA. Our null hypothesis is beta equals 0, and our alternative hypothesis is beta does not equal 0. We chose this hypothesis because we wanted to test if there was a correlation between these two events. Since we were not sure what the correlation would be, a two-sided linear regression t-test would be able to tell us if there was any kind of association. There have been many studies dealing with the association between extracurricular activities and GPA. Two studies have been done by Dr. Lance Kelvin Reed and Robert Freeman, both of which concluded there was a moderate positive association. This leads us to believe we will reach similar results between the association of extracurricular participation and GPA.
So our population of interest for the survey was all students at Leesville Road High School, and to obtain our samples, we got a list of all staff members from the website, and we copied and pasted it into an Excel spreadsheet column. And then we created a second column that used this formula here to randomly select 8 teachers from this list. And then we passed out the survey to 7 of those teachers who responded, and we got 163 usable results, and this is the survey we used here to do it. So this is our scatter plot, and as you can see already, there's probably not going to be much of an association. But our least slope regression line, with y hat being the predicted weighted GPA and x being the extracurricular hours per week, was y hat equals 3.4356 plus 0.006878x, and r being 0.07226, meaning that there appears to be a weak positive linear association. R squared was 0.005221. So 0.5221% of the variation in weighted GPA can be explained by the student's extracurricular hours per week. This is our residual plot for the data. It doesn't show any clear pattern, which suggests that there is a linear association, which also covers one of our assumptions for our linear regression t-test. So for our linear regression t-test, our parameter of interest was, of course, the true slope of the regression line between hours spent by LRHS students doing extracurricular activities and their weighted GPA. Our null hypothesis was that the slope was 0, and our alternative was that it was not 0. All the assumptions checked out except that the association was weak, with the R value being just 0.07226. But besides that, it was an SRS. The residual plot showed no pattern, and the normal probability plot appeared linear. We did all our calculations, which are shown at the bottom there, and we ended up with a p-value of 0.3594. So we very much failed to reject the null hypothesis at the 5% significance level and concluded that there was not enough evidence to confirm that there is a useful linear relationship. One issue with our study is that GPA is noticeably influenced by grade level, and we think our data would have been more accurate, maybe shown more of a correlation if we had differentiated between grade levels. Another issue is that there was a major lurking variable. We initially intended to see if more extracurricular activities would take time away from studying to lower your grades, but more motivated students will likely have higher grades and more extracurriculars, so that kind of counters the other variable. For extrapolation, our population was all LRHS students, but we feel comfortable extrapolating this to all U.S. public high schools. We don't see any major variables changing between those, so we don't see any reason not to be able to do that. If this were to be replicated, we'd recommend adding a question to the survey asking what grade level respondents are in, and then using that to create a scatter plot with 4 different colors, each color being a different grade level, and we believe that that would show more accurate results and more correlation between the two variables. And then, if possible, the population and the extrapolated population could be expanded by surveying multiple schools, like public and private, or even from different countries, to expand like the population that this would be useful for.
Our data fails to show a significant correlation between the two variables. We believe our inconclusive data has mostly resulted from too much variation in our sample. More blocking will likely show stronger correlation within each separate grade level closer to background research.